Section 4, partial fraction decomposition theorem. Here's what we're doing today. We are going to look at a fraction, a polynomial fraction, or a rational expression it is called, and separate it into fractions that could be used to add together to make that original fraction. Let me just give you an idea. If I had two fractions that I was asked to add, like 2/3 plus 5/7, so that you could get one fraction from it. Well, we know that if I'm going to add fractions, I have to have common denominators. It would be 21 in this case. So this one would become 7 times 2 is 14, and 7 times 3 gives my 21, so 5 times 3 is 15. So I get 29 over 21. 29 over 21. Partial fraction decomposition says, hey, we're going to give you a fraction. We want you to figure out what two or more fractions could be added together to make that one. But it'll be in polynomials. It won't just be in numbers. That's what partial fraction decomposition is. To decompose means something is breaking apart. In math, when we decompose, nothing stinks, so that's nice. We are breaking apart a fraction into its partial fractions. Partial fraction decomposition. So we have one polynomial divided by another polynomial that we want to separate. So when we're all done, we can just add them together and they equal the original thing. Now, there are going to be two forms when we break these polynomial fractions apart, or these rational expressions apart. Two forms that they will take. It will either be one number on top, like 2 over the polynomial, or it's going to be in the form like this, which is 2x minus 7 over a polynomial. So it's going to be one of those two forms. And how we tell what the fraction form will take is we look at the denominator down here, and if it is a first degree, there's just going to be a number on top. 2, negative 17, something like that. If it is a second degree on the bottom, then it's going to be a linear polynomial on top. ax plus b, 2x minus 4, something like that. So we will be splitting it apart, and they will take one of those two forms. The next thing we learn about partial fraction decomposition is when we look at our original polynomial that we're trying to break apart, we need to make sure that the denominator is factored. Once we have the denominator factored, then we can tell how many fractions we are going to get. You notice there are 1, 2, 3 factors. And every one of those factors becomes its own fraction, and those factors are all the denominator in its own fraction. Now in this example, since these are all first degrees, x to the first, 3x to the first, x to the first, then on top we're just going to have numbers. And so we usually just go down the alphabet. The first number we call A, the next number we call B, the next number we call C, the next number we call D. We just run down the alphabet. So let's practice this. Let's see how this works now. So they want us to find the partial fraction decomposition of this. Well, step number 1 is I need to factor this denominator. It needs to be in factored form. So that's a nice trinomial. Help me with the numbers. What would factor? 5 and 3. Negative 5, positive 3. So we are going to rewrite this original fraction in its factored form, x plus 11 over x minus 5 times x plus 3. So when we decompose it, it's going to decompose into two fractions, and each of those fractions will have one of these factors on the bottom, x minus 5, x plus 3. And the form that goes on the top, well, these are both first degree, and so it's just going to be a number. We'll call that one a, and we'll call that one b. So step number 1, factor the denominator. Separate into as many fractions as we have denominator factors. Then we have written an equation here. This original fraction is supposed to equal the sum of these other two. Then we are going to multiply We need to get that room up there to quit jumping up and down. Then we are going to multiply both sides by the least common denominator. Now, the least common denominator is always going to be the denominator of this first thing. X minus 5, x plus 3. So what we are using is the idea that I can multiply both sides of an equation by the same thing, and it still is equal. So this will help us rewrite it in a different form. So if I go to multiply right here, well, x minus 5 would cancel, x plus 3 would cancel, and all I would have is x plus 11 equals. Now I need to go distribute times this. Well, x minus 5 would cancel, which means that x plus 3 needs to be multiplied by the a. What would you get if you multiplied that together? ax plus 3a. And then we need to distribute or multiply by this last thing down here, x plus 3. I'm going to go ahead and cross it off because we're the last thing we need to use. So x minus 5 needs to be multiplied by b plus bx minus 5b. So I have no fractions here. We cleared the fractions by multiplying by the least common denominator. Next thing we're going to do is get like terms together on the right side. There's an x term here and there's an x term here. ax plus bx. This is a constant or a number. Remember, a and b are going to be some numbers. So that's a number and this is a number. So I'm going to write those together. Plus 3a minus 5b. Now right here with the x term, I'm going to factor out the x. But I'm going to factor out the x on the right side instead of factoring out the x on the left side like we normally see, and we'll see why I'm doing that in a minute. So a plus b, factored the x out. If I distribute it back in, it's ax plus bx. Plus, I'm going to write this in a set of parentheses, 3a minus 5b. These two sides are equal to each other. A and b stand for some number. 3a minus 5b, that stands for some number. And if these two sides are equal, this a plus b is the coefficient of the x. What is the coefficient of the x on the left side? 1. It implies that whatever a and b are, when I add them together, they must equal 1. Because they're the coefficient on the x, and the coefficient on the x is 1. And whatever 3a minus 5b is, it must equal, can you finish that sentence? It must equal 11. Because this 3a minus 5b is the constant, and 11 is the constant over here. Now I can solve this using some of these substitution or elimination techniques. I'm going to use substitution. I'm going to solve for a. A is, if I subtract b, 1 minus b. So right over here, 3 times a, which is 1 minus b, minus 5b equals 11. So 3 minus 3b minus 5b equals 11. What's that? Negative 8b. And if I subtract 3, what's b? B is negative 1. And what's a? 2. A must be 2. Oh, now I know the fractions. Back up here, I know my fractions now. My answer is a, which is 2 over x minus 5, plus b, what's my b? A negative 1? Negative 1 over x plus 3. There's the partial fraction decomposition of this lovely first rational expression. I can add those two fractions down there and it equals that original one. Decomposing or separating that fraction. We are going to see different examples from here on out of this same process. This is partial fraction decomposition. What's different here? Well, if you notice here, they have written the denominator factored, but this factor happens to be squared. So that x minus 2, I have to write it one time x minus 2 to the first, and I don't need the first, and then write it x minus 2 squared. And then I have my 2x plus 1, my 2x plus 1. What they're telling you is if you have a factor that's raised to a power, you have to have the same number of fractions as that power. If this was x minus 2 cubed, I'd have one fraction, x minus 2, and then another one, x minus 2 squared, and then a third one, x minus 2 cubed. Whenever I have a power, I'm going to have that many fractions, starting at the first, and then going all the way up to that power. So we're going to see one right down here. Find a partial fraction decomposition. Well, this one already is factored form, and there is something that is squared. So x squared plus 2x plus 7 over my x times x minus 1 squared. When I break it apart, I'm going to have one fraction with an x on the bottom. I'm going to have another fraction with an x minus 1 on the bottom. And then another fraction with an x minus 1 squared on the bottom. Now all of these are still linear. X to the first, x to the first, x to the first. So I just have the numbers. A, B, C, and we just go down the alphabet. And then again, I'm going to clear fractions. And I'm going to show you a little shortcut a little bit later on as we get to it. So if I'm going to multiply everything by this, well, I know my first fraction denominator just cancels all out. X squared plus 2x plus 7. Now over here, x cancels, so I have to multiply that a times x minus 1 squared. So maybe I better know what x minus 1 squared equals. Can you tell me the answer? What is x minus 1 squared?
X squared minus 2x plus.
There it is. So I'm going to have to multiply a times that thing. Ax squared minus 2ax plus 1a. Then I go to the next one, x minus 1. That takes care of one of those x minus 1s. It's not squared anymore. It's just x times x minus 1. Well, again, what does x times x minus 1 look like? That's what it looks like. So I need to multiply b times that. So plus bx squared minus bx. And then there's the x minus 1 quantity squared, so that gets rid of the whole thing. What's left? Cx. X times that c, so plus cx. Now here's the little shortcut that I would do. Let me recopy this left side. X squared plus 2x plus 7 equals. I want to get my x squared terms together. So I am just going to write all the coefficients of my x squared terms. I have an a, I have plus b. Those are all my x squared terms. I've pre-factored it. There it is. I've got it all factored out. Then I'm going to work on my x terms. What are all the coefficients that go with the x terms? Negative 2a, negative b, plus c. Those are all the x terms. And then I go for all the constants, which is everything else that doesn't have an x with it. So as I come across here, oh, I've got an a. Is that all I have? That's all I have. So you look at this, tell me what a plus b equals. Equals 1. Because the coefficient of the x squared term is 1. And what does all this stuff equal? That all equals 2. Negative 2a minus b plus c, it all equals 2. And finally, a equals, oh, that was kind of nice. So right here, I actually already know one of those answers. So it's going to be pretty easy. 7 plus b equals 1. What does b equal? Negative 6. And once I have two of them, I can just substitute into, oh, this bouncing. I can just substitute into this middle one right up here. Negative 2 times our a, minus our b, now minus a negative 6, plus 6, plus our c is 2. What's that? Negative 14 plus 6? What's negative 14 plus 6? Negative a, plus c is 2. What's c? How much? C is 10. So I have all my values. I can write my solution. A Where's my a? 7. 7 over what? 7 over x. Plus, help me out. Negative 6. X minus 1. And 10 over partial fraction decomposition. So now let's look at the type where I have a second degree in the denominator, right over there, that x squared. Notice when we have the x squared that the numerator takes on a different form. There's that ax plus b. Now that x minus 4 still just has a number over it, c. So we're going to see this type now. So 3x plus 16 over x minus 2, x squared plus 7. I have, they already factored it for me. I have an x minus 2. That's just going to be, if I can get the right number, just one number on top, so we'll call it a. I have an x squared plus 7. And that, being a second degree, is going to take, I just go to the next letter in the alphabet, I've already used a, bx plus c. That's the form it's going to take on top. And we again, x minus 2, x squared plus 7. And the first ones cancel. And x minus 2 cancels. What do I get with the a? X squared plus 7 canceled. What do I have to do here? FOIL. I've got to multiply that together. So I'm going to take my first terms, bx times x, bx squared, outside plus cx, inside minus 2bx, and last terms minus 2c. And then I again am going to collect like terms. I'm going to start with my x squared term. A, what do we have? A plus b. That's my x squared. My x's. C minus 2b. And my constants, what will they be? I forgot to write my x there. 7a minus 2c. 7a minus 2c. They have no x's. They're just the constants. So this implies that a plus b equals what? Things have to look like a plus as you're thinking about it.
Oh, 0.
Why 0?
Because there's no x squared term.
There's no x squared term. So I must have 0 x squareds, because there aren't any x squareds on the left. So it must equal 0. And the c minus 2b equals 3, and the 7a minus 2c must equal to 16. So I have a system of 3 equations that I'm going to work with. I'm going to do some elimination. I'm going to take these two. I'm going to eliminate the b's. So I'm just going to multiply this one by 2. So I'd have, let me write it all out. I'd have 2a plus 2b equals 0, since 2 times 0 is still 0. C minus 2b equals 3. And when I eliminate my b's, but I still have a and c. 2a plus c equals 3. But that's okay. I've used the first two. I now need to use the last one. Well, I can put those together. They're each in terms of a and c. So let me bring my 2a plus c over here, equals 3. And I'm now going to work on these two. I'm going to eliminate my c's. Multiply by 2 would eliminate my c's. See if we can do this in our heads. 7a plus how many a? 4a, so that'd be 11a. Negative 2c plus 2c, so that's gone. 16 plus 6 is 22. A equals 2. So A equals 2. Let's come right up there. A is 2. What is B? Negative 2. And what do I need? A C somewhere. Let's use that one. C minus 2 times B, which is negative 2, equals 3. So C plus 4 is 3. What's C? Negative 1. So we've got everything we need. We're ready for our lovely answer. What is A? 2 over x minus 2. And then we have bx plus c. So negative 2x minus 1. Negative 2x minus 1 over our x squared plus 7. So let's make it even more interesting. And how do we make it more interesting? We take the second degree equation and we raise it to a power so that I have to write it not only just once, but I have to write it twice when we do it. So right down here, they have a second degree equation, which, by the way, if you tried to factor that, it wouldn't work. And it's to the second power, so I'm going to need 2 of those lovely things. 4x cubed plus 5x squared plus 7x minus 1 over. Now, as I'm writing this, and you notice it takes me a little while to write all this, and as you anticipate writing it, be careful of the details, because that's where you usually make a little mistake on these. These tend to be not hard, but a little long. What form goes on top? It's a second degree. What does it look like on top? ax plus b is what it looks like on top. Now what do I write over this one? Yeah, it's the same form, but I just go down the alphabet, cx plus d. And so when we multiply by x squared plus x plus 1 quantity squared, well, the first one just all cancels out. This cancels out one of them, and I still have an x squared plus x plus 1 that I have to multiply by this. So how do I multiply trinomials and binomials? I distribute. I'm going to take that ax and multiply it by everything back here. Ax cubed plus ax squared plus ax. Then I'm going to take the b and multiply it by everything back here. Plus bx squared plus bx plus b. And make sure you have lots of room. Now when I go to multiply here, well, the nice thing is everything's gone. All I have left is plus cx plus d. And so once again, we're going to collect our like terms. I'm not going to finish this one all the way out, but I do want to finish it through our like terms here. A, my cube term, that's all I have. A is my cube term. My squared term, I have an A, I have a B, that's my squared term. Just my x to the first term, I have an A, I have a plus B, I have a plus C, those are my x terms. Then my constants, I look for anything that doesn't have an x, b and d. b plus d. So 4x cubed plus 5x squared plus 7x minus 1. You know what to do now. A equals what? 4. A plus b equals 5. A plus b plus c equals 7. And b plus d equals -1. So you'll finish it out because you're the student and you get to do that. Right over here. What do I do when the degree of the numerator exceeds the degree of the denominator. This is a third degree over a second degree. All the others, the numerator degree has been less. This is a first degree over, it actually would be a fifth degree down there on the bottom. All the other numerator degrees have been less than the denominator. If we run across a situation like this, I first need to do long division, because it actually will divide into it. So this big long thing divided by x squared minus 7, or x squared minus 7x, we are going to do some long division. X cubed remember how to do long division? What do I need to do with this x squared and that x cubed? Multiply it by x. So I'm going to take that x times what is in front, x cubed minus 7x squared. I'm going to change my signs and add it together. So my squared terms, I get 3x squared, bring down negative 19x minus 35. What goes next? Multiply by 3. X squared times 3 would be 3x squared, so plus 3. 3x squared minus 21x. Change my signs. Negative 19 plus 21, so we have 2x minus 35. What do I do now? That's the remainder, or it's the fraction that is left, plus 2x minus 35 over what? X squared minus 7x. So this is the part that I'll do the partial fraction decomposition on, and I won't forget that I have an x plus 3 plus the fractions that I get from the partial fraction decomposition. So we'll just set aside the x plus 3 and we'll work on decomposing that thing. Now if I decompose it, I want that denominator to be factored. So how do I factor that x squared minus 7x? It's hard to stay awake. What's common? X squared minus 7x. Just take out the x. Factor out the x. What is left? X minus 7. So now I have my denominator factored. Now I know there are going to be two fractions that it will decompose into. What will be the denominators? X and x minus 7. What will I have on top of each of these? Just a and b. They're linear. So let's clear our fractions by using the x times x minus 7. So 2x minus 35 must equal ax minus 7a, because x would cancel. Ax minus 7a plus bx. So I have a plus b are my x terms, minus 7a is that constant term. So I know a plus b must equal 2, and negative 7a must equal a negative 35. That looks like a good place to start. What does a equal? A is 5. What's b? A is 5. Negative 3. So I have my answer, and my answer must include the x plus 3 plus the partial fractions. X plus 3 plus, and then my two fractions. What is it? 5 over, where did it go? 5 over x, and the negative 3 over the x minus 7. And we have simplified that fraction. First by dividing it long division, and then by partial fraction decomposition. Your turn for fun.